Thank you for tuning in. Today we're going to be covering 9A, which is solving two-step equations. Content objective, students will be able to solve two-step equations with rational numbers and check their solutions. So just a friendly reminder, rational numbers will include decimals and fractions. Our language objective is students will be able to state the mathematical properties used when solving equations. Why am I learning this? Well, it's important for real-life problems like helping you to decide how much pet food to purchase. So first thing we're going to do is cover some background knowledge. So in our previous lesson, we went over one-step equations. So here, what I showed you was we isolate the variable by doing the inverse operation. So here you would have had to add 2/3 to both sides. And then leaving you with, these are additive inverses, leaving the side with 0. So 0 plus c is just c. And we did the side work here and we got an answer of -77/5. So hopefully that looks a little familiar to you. And we also have another example. So let's try that. And this one here, same idea. This was from our previous lesson. We are trying to isolate the variable, so we use the inverse operation. Since 2 4/10 m means 2 4/10 times m, times m, the inverse operation will be to divide both sides by 2 4/10. And after dividing, first of all, these are multiplicative inverses, creating 1 times m is just m. And after dividing off to the side, we figured out it was -1 6/10. So this is just trying to get your brain remembering how to do those steps so we can learn today's lesson. So here is just a quick example from 7th grade where we went ahead and after every single step we did, we justified it. So here, what's first, you're going to want to get rid of the 6 by adding 6 to both sides. This is the addition property of equality because you're adding the same value to both sides to keep it balanced, keeping that equality there. And then after that, here, this means x divided by 7. So the inverse would be to multiply both sides by 7. Therefore, I'm using the multiplication property of equality since I'm multiplying both sides by 7 to keep my equation balanced. And then once I solve, I would make sure I check my answer by plugging in the value in for x, making sure I include parentheses, and then evaluate what I have, check to see if I'm left with a true statement. I do, so that means my solution is correct. If you get a statement that is false, that means your answer or solution is incorrect, and you may want to go back into your work to see where it went wrong. So vocabulary, some more background knowledge. Inverse operations, we need to remember that these are the operations that undo each other. And you're going to use this a lot in order to isolate the variable to get a solution. So addition and subtraction are inverse operations. So here you can subtract 7 or add 7. Those are inverse operations. Please do not confuse that as with a positive 9 and a negative 9. Those are additive inverses. So there's a slight difference there. Same thing with multiplication and division are inverse operations. So an example might be multiplying by 3 and dividing by 3 are inverse operations. However, 9 and 1/9 are multiplicative inverses because these are reciprocals of each other, making them multiplicative inverses. So last vocabulary background are the 4 types of property of equalities. Basically, this is what's going to allow you to keep your equations balanced. You've heard it before, whatever you do to one side, you must do to the other. So whichever operation you're using is going to determine which of these properties you are applying in order to find your solution. So here's our first equation. So remember, today we are covering two-step equations. In our previous lesson, we covered one step. Today it's two-step. Basically, it's an equation that requires 2 steps to find the solution. So please make sure you copy all the steps in your notes. That way, if you get lost, you can refer to your notes to help guide you. So same thing as always. I'm going to go ahead and follow the same steps as I did from my previous lesson. I'm working on isolating my variable. So notice I like to circle it just so that I can see where my focus is going to be. Since x is on the left side, I'm making sure I'm focusing on the left. And the first thing I'm going to do is decide what should I get rid of first. Should I get rid of this coefficient or should I get rid of this constant? You're going to learn that getting rid of your constant is going to be easier. And the reason why we get rid of the constant is because you're undoing addition or subtraction. And you're going to find that this is a lot easier than doing multiplication or division first. So that's what I'm going to do. The inverse of adding 1 and 2/3 would be to subtract 1 and 2/3. These are additive inverses, creating 0. But whatever you do to one side, you must do to the other. So 1 and 2/3. This is using the subtraction property of equality. So notice, since I'm doing the same to both sides, I'm keeping it balanced, and that's using the subtraction property of equality. So here, for some side work to figure out what that is, I'm going to go ahead and say negative 7.5 is equivalent to 15 halves. I'm going to subtract that from 1 and 2/3, which is equivalent to 5/3. My lowest common denominator is a 6. Let's see, and now in order to determine what this new fraction is going to turn into, I'm going to have to multiply that by 3, leaving me with negative 45. And then here, I'm going to have to change the denominator up by 2 to make it a 6. I'm left with negative 5 times 2, which is negative 10, which leaves me with negative 55 over 6. This is simplified, so I'm going to go ahead and say that this equals negative 55 over 6. And here I'm still left with 3x. So 3 is your coefficient. This means 3 times x. So in order to isolate x, I must do the inverse, so therefore I must divide both sides by 3. These are multiplicative inverses, creating a 1. 1 times x is just x. But since I divided the left side by 3, I'm also going to divide the other side by 3. So I have an option. I can also choose to write divided by 3 like this. However, that creates something that I'm not familiar to seeing. So I'm going to suggest that you instead write it like this: divided by 3. It means the same thing. However, you might be more familiar with this. In fact, putting it over 1 will make it even more familiar for you to recognize. So off in my side work, I'm going to go ahead and compute this. Before I do, I'm going to decide that a negative divided by a positive is a negative. So now you have negative 55 over 6 divided by 3 over 1 is equivalent to negative 55 over 6 times, let's change the color there, times, because we're changing it, the reciprocal, which means now I'm multiplying by 1/3. I can't cross cancel, so I'm just going to multiply straight across, leaving me with negative 55 over 18. This cannot be reduced, so I'm going to go ahead and say that my answer is negative 55 over 18. Now, on your homework, I am going to be expecting you to check your answers, so I'm going to go ahead and demonstrate how I would set that up, but I'm not going to show you all the steps. But let's take a look. First things first, you're going to write down here, you're going to write down your equation. So I'm going to write 3, but instead of an x, I'm going to go ahead and plug in my value, which is negative 55 over 18. Then I'm going to continue to write the problem down, plus 1 and 2/3 equals negative 7.5. So once you simplify and evaluate what you have here, you should end up with a true statement. If you don't end up with a true statement, that means your solution is incorrect and you're going to have to try it again. Okay? So that concludes our very first example. So let's just go ahead and move on. So now, the rules for transforming equations. We've gone over this with the previous lesson, but I have an extra rule for you to write down. So go ahead and write this down. Our first goal is to get the variable on one side of the equation by itself. I refer to this as isolating your variable. Number two, always perform the same operation to both sides of the equation. So this is using the different properties of equality, whether it's addition, subtraction, multiplication, or division. Number three, to undo an operation, perform its inverse operation to both sides of the equation. And number four, addition and subtraction are inverses, multiplication and division are inverses. Number four, always show all of your steps. And last but not least, you're going to notice today it's a lot easier to undo the addition or the subtraction first versus doing multiplication or division. So let's jump into our very next example. So continuing with the pattern that I've been doing, I'm going to go ahead and circle my variable. This means I'm going to focus my attention to the left side. I told you before it's going to be easier to get rid of your constant. Why? Because it undoes addition or subtraction. And if you're wondering what a constant is, if you forgot, it's basically your number without a variable. So notice this is going to be my constant because it has no variable attached to it. This one does. This is what we would call a coefficient. Some of you may be saying, well, 1 1/2 is a constant. You're correct. But noticing my goal is to isolate x. So the only thing that I should be focusing on is this constant. This needs to be removed so that I can get closer to isolating my x. So I'm going to go ahead and do the inverse operation of adding 2 1/4 by subtracting 2 1/4 to both sides. This is an additive inverse, so that creates 1. Whatever you do to one side, you must do to the other. So since I'm subtracting from both sides, this is a subtraction property of equality that I'm using. So now let's see what we have here. I'm going to do some side work. Let's see, 1 1/2 is equivalent to 3/2. I'm just converting that to an improper fraction. Negative 2 1/4 is equivalent to 9/4. And again, I'm just turning it to an improper fraction. Where 4 is going to be my lowest common denominator. 2 is going to have to change by 2, leaving me with a numerator of 6 here. My denominator is not going to change, so my numerator will not as well, leaving me with -6. Now that leaves me with -3/4. So I'm going to write that down. I simplify this to -3/4. This is gone because those are additive inverses. I'm just left with -3/8x. Now we went ahead and got rid of our constant. The second thing we're going to do is get rid of our coefficient. Our coefficient is your term being multiplied by the variable. So it's always a number right next to the variable. So again, this means -3/8 times x. So in order to do the inverse, I'm going to have to divide. So I'm going to go ahead and show that by creating a fraction. I'm dividing by -3/8. These are multiplicative inverses, which is going to leave me with 1. 1 times x is just x. But whatever I do to one side, I must do to the other. So I can choose to also create a complex fraction like so. However, some of you are not going to be familiar with this, so I would suggest that you instead write it like this. It means the same thing, divided by -3/8. So I'm not sure if you remember this from the previous lesson, but I kept stressing that you need to make sure you write off to the right. And here's a great example. If you wrote this off towards the left, you would have created a completely different problem because division doesn't have a commutative property. So the order of the numbers really does matter. So now, I don't know this answer off the top of my head, so I'm going to have to do some side work. Before I do that, I'm going to decide is my answer negative or positive. Well, negative divided by negative is a positive. So I know that to be true. I'm going to go ahead and do some side work. We have 3/4 divided by 3/8, which is equivalent to 3/4 times the reciprocal. So I'm going to multiply that by 8/3. Can I cross cancel? Well, let's see. 3 and 3 have a 3 in common, turning it into a 1. 4 and 8 have a 4 in common, so 4 divided by 4 is 1, 8 divided by 4 is a 2. So multiplying across, 1 times 2 is 2, 1 times 1 is 1, which is equivalent to 2. So I'm going to say that my answer is x equals positive 2. But once again, you're going to have to check in your work. So you're going to have to check your work. So please make sure you plug back into x and see if you end up with a true statement. If you do not remember how to check your work, I will be linking a video from the previous lesson that gives you examples of how to check your work. So click on that link if you need the help. Otherwise, we're moving on. Okay, so for number 2, what I'm going to go ahead and suggest you do is pause the video if you're ready, try it out on your own, and see if your answer agrees with mine. But hopefully, you're checking your work and seeing that you have the right answer, and you're just checking it with mine. So now let's see, what am I going to do here? Same step as before. I'm going to circle my variable so that I can see that my focus is on the left side of my equation. So here I'm strictly looking on this side. I'm kind of ignoring the 9 2/10 for now. Again, it is easier to get rid of your constant first because you are undoing the addition or subtraction. So here my constant, once more, is your number without a variable. So I'm going to go ahead and get rid of this negative 23 3/10 by adding 23 3/10. These are additive inverses, creating 0. Now here I must add 23 3/10. That's using the addition property of equality. So now this leaves me with, well, 0 minus 5c is just negative 5c equals, here I don't know this answer off the top of my head, so I'm going to have to go off to the side. They're both positive, so I know my answer is positive, so let's figure it out. So notice as I'm adding these fractions, I'm making sure my decimals line up. That's very important. Some of you guys are forgetting to line up that decimal, so it kind of ruins your answer. Not kind of, it totally ruins your answer actually. So here, 3 plus 2 is 5, bringing that decimal down. 3 plus 9 is 12, carry the 1. So I have 32 5/10. Now the last step is to get rid of my coefficient. You're going to notice your coefficient is, the only way to undo it is either by multiplying, undoing multiplication, or undoing division. So here, what does negative 5c mean? Well, it means negative 5 times c. So the inverse operation would be to divide by c. So I'm going to do that. I'm going to divide both sides by negative 5. These are multiplicative inverses, creating 1. 1 times c is just c. But whatever I do to one side, I must do to the other. Now, before I do some side work, let's decide right now, is my answer negative or positive? Well, positive divided by negative, that is going to be a negative. Now let's figure this out. 32 5/10 divided by 5. So bringing up that decimal, 5 cannot go into 3. 5 can go into 32 6 times, with a remainder of 2, bringing down that 5. 5 can go into 25 5 times evenly. So I'm going to say my answer is C equals negative 6 5/10. But once more, before you finally claim this as your solution, you need to make sure you plug in negative 6 5/10 back in for C to see if you end up with a true statement. Because a true statement means that you have the correct solution, but a false statement would mean that you did something incorrectly and you need to check it out because it's not the correct solution. Hopefully, after checking your answer, for those of you who pause the video, you have the same answer as mine. Now, let's just keep moving on to example number 3. So once more, if you're ready, go ahead and pause the video and try this one on your own. If you want a little bit more support, go ahead and take notes as I go over number 3 with you. So now, first things first, like I always do, I'm going to circle my variable and say that my focus is going to be to the right this time. So nothing's changed really. I'm going to go around the same steps, except now, instead of focusing on the left, I'm focusing on the right. You're going to get rid of your constant first, and that means you're going to be undoing addition or subtraction. So my constant once more is my term without a variable. So I'm focusing on -3/2. So in order to undo subtracting 3/2, I'm going to add 3/2. These are additive inverses, leaving me with a 0. And 0 plus 5/2 d is just 5/2 d. But whatever you do to one side, you must do to the other. And notice I'm going to write it off to the right side, not to the left. So I don't know the answer off the top of my head, so I'm going to do some side work off to the side. Notice we read from left to right, so I'm going to have to write the -1/2 first. So I have -1/2. Then I'm going to add that to 3/2. Luckily here, the denominators already match. So I just need to combine the numerators. -1 plus 3 is 2, a positive 2, and 2 over 2 is equivalent to 1. So now I'm left with 1 equals 5/2 d. Now I need to get rid of the coefficient. And again, the coefficient is your term that's being multiplied by the variable. And we normally get rid of the coefficient by undoing multiplication or division. So here 5/2 d means 5/2 times d. So the inverse would be to divide by 5/2. So notice I write it like this to see that these are multiplicative inverses. They're going to create 1. 1 times d is just d. But on this side, I'm not going to divide by 5/2 like this because it creates a problem that I'm not used to seeing. So I'm going to go ahead and make it a little bit easier for me and write it as divided by 5/2. Now this is a little bit more familiar because if you look over here, if I do some side work, I'm going to write it as 1 over 1 divided by 5/2. All I had to do was simply write 1 into a fraction by putting it over 1, and now it's a familiar type of problem. So I'm going to go ahead and rewrite this as 1 over 1 times the reciprocal of this, which is 2/5. I'm just going to multiply straight across since there's no cross-canceling involved. So I'm left with d equals 2/5. And again, before I claim this to be my answer, I need to make sure I check my work by by substituting in 2/5 to check to see if I have a true statement or not. Otherwise, that's it. Okay, so now for sure, you must pause the video right now and try number 4 on your own. Okay, so now we're going to check our work to see how well you did on number 4. So first things first, I'm going to go ahead and circle my variables so that I know that I'm focusing my attention on the right side of the equation. So we're going to ignore -6 8/10 for right now. I'm going to go ahead and get rid of my constant first. Again, that's just undoing addition or subtraction. Here, since it's plus 15, I'm going to undo it by subtracting 15. These are additive inverses, which create 0. So I'm just left with -3 and 2/10 x on this side. But whatever you do to one side, you must do to the other to keep it balanced. This is basically using the subtraction property of equality since I'm doing it to both sides to keep my equation balanced. Now here, I don't know the answer off the top of my head, so I'm going to do side work. Before I do that, I can decide right now that there are more negatives, so I'm going to mark that right away so that I don't forget. Let's go ahead and combine 6 8/10 with -15 to see how many negatives I have all together. Notice I put my decimal after the whole number. That's where it always belongs if you have a whole number. Combining these together, I'm left with 21 and 8/10. Now, the next thing I'm going to do is get rid of the coefficient. The way you get rid of the coefficient is by undoing multiplication or division. And again, your coefficient is a term that's being multiplied by the variable. So it's the term it's the number right in front of your variable. So here it means -3 and 2/10 times x. So the inverse would be to divide by -3 and 2/10. to both sides. These are multiplicative inverses, making a 1. 1 times x is just x. But whatever you do to one side, you must do to the other. So I'm going to go ahead and divide this side by a negative 3 2/10 as well. A negative divided by a negative is a positive. Now I'm going to do some side work to figure out what this answer is. We have 21 8/10 divided by 3 2/10. I want to divide by a whole number, so I'm going to move my decimal over once to the right. I must do the same to the dividend. Bring the decimal up. 32 cannot go into 2, cannot go into 21, but can go into 218 6 times, which gives me, let's see, that's 12. Carry the 1, that's 18 plus 1 is 19. Need to find the difference. 8 minus 2 is 6. We need to borrow for this one. It's making this 11. 11 minus 9 is 2. Bring down a 0. 32 goes in 216 8 times. 8 times 2 is 16. Carry the 1. 24 plus 1 is 25. Subtract. I'm left with, let's see, borrow. You have a 4. Bring down a 0. That's going to go in once with a remainder of 8. Let's see. And then bring down another 0. That's going to go in about, let's see, 2 times. We're leaving us with 2 times 2, which is 4, 2 times 3, which is 6, with a remainder of 160, and that's going to go in 5 times. Exactly. So notice this was just a long answer. It doesn't mean my answer was wrong. It was just a little bit more time consuming. So I'm going to say that my answer is a positive 6 and 8,125 10,000ths. And once more, before I can claim this as my answer, I need to substitute this value in for x to make sure I end up with a true statement. So one thing about this problem is sometimes I notice my students, when they divide and they notice that it keeps going on, sometimes they get the impression that they're doing something wrong. That's not always the case. As for this one, we had to go all the way to the 10,000ths place. I wasn't doing anything wrong. It was just, it didn't go in to the tenths or to the hundreds. We just had to keep going. So please don't always be discouraged. Sometimes it's a good idea to check just in case, but don't always assume that you're doing it incorrectly just for this reason. Okay, so we're ready to move on to the next one. I'm going to go ahead and move a little bit quicker with less of me talking, basically. So first of all, let's go ahead and circle our variable like we always do. Oh, I like to start with blue first. I'm going to get rid of, first of all, I'm focusing on the right-hand side. Going to get rid of my constant first by subtracting. These are additive inverses, creating 0. So I'm just left with 1/5 m equals whatever you do to one side, you must do to the other. Oops, I subtracted from the right side, so I must subtract to the left side as well. There are more positives. Let's see how many positives there are. We're going to do 9 8/10. Subtract 6 3/10. The remainder, not remainder, with a difference of 3 5/10. So notice now we have a decimal and a fraction. So your choice in class, I did suggest that you went ahead and converted decimals to fractions. So for this case, let's go ahead and try that out. 3 5/10 or 3 1/2 could be written as such. So if you read it as 3 5/10, you would notice you can divide by 5 to both the numerator and denominator, and you would still end up with 3 1/2. That's just 2 ways of reading the same thing. All of these are equivalent. Okay, so I'm going to go ahead and rewrite this as 3 1/2, but since I want to make it improper, let's go ahead and change that to 7 halves. 7/2 equals 1/5 m. Now I need to get rid of the coefficient. Since this means 1/5 times m, I'm going to go ahead and divide both sides by 1/5. These are multiplicative inverses, creating 1. 1 times m is just m. Now here, instead of making a complex fraction once more, I'm going to go ahead and just say divided by 1/5. Now here, since they're both positive, I know for sure my answer is going to be positive, but I'm going to have to compute some side work here. We have 7/2 divided by 1/5, which is equivalent to 7/2 times the reciprocal of this, which is 5/1. I can't cross cancel, so this is going to give me 35/2. This cannot be further reduced, so this is going to be my answer. However, if you chose to go ahead and work it out with decimals, an equivalent answer to this would then be, let's figure this out. Goes in 2 times with the remainder of 1, bring down that 5. Goes in 7 times with the remainder of 1. Let's bring down, put our decimal, bring down a 0. And that's going to go in evenly 5 times. So an equivalent answer could have been, is also, m equals 17.5. Okay, and once more, you would still have to check your work by plugging that value in for m to see if you end up with a true statement. Moving on. So now here, once more, we're given both decimals and fractions. So now, I'm going to go ahead and show you what it would look like if I went ahead and changed it into a decimal instead. And the reason why I'm choosing to do it for this problem is because I know what -1 1/10 looks like. It's pretty simple. As a decimal, I would write it as -1 1/10. So that's easy. So I'm going to go ahead and change this to a -1 1/10 equals 2h minus 3 2400ths. Like always, I'm going to circle my variable and notice that I'm focusing my attention to the right side. I'm going to get rid of my constant first by adding 3 2400ths. This creates 0. Whatever I do to one side, I must do to the other. So here I'm just left with 2h equals, here I'm left with more positives. How many more positives are there than negatives? So let's figure that out. I need to find the difference between the two. Notice I'm lining up those decimals. Make sure you do the same. So this leaves me with positive 2 1400ths. But now, in order to isolate my variable, I need to get rid of this 2, the coefficient. This means 2 times h, so I must do the inverse, which is dividing by 2. These are multiplicative inverses, making 1. 1 times h is just h. Now here, a positive times divided by positive is a positive. I'm going to have to do some side work. 2 1400ths divided by 2. Bringing up that decimal that goes in once. Bring down that 1. Here, be very careful. How many times does 2 go into 1? 0 times. Make sure you have that 0. So that's going to be 0 with a remainder of 1. Bring down that 4. 2 goes into 14 7 times evenly. So my answer is h equals 1 700ths. So if you wrote these as a fraction, what would your answer be? An acceptable answer would also be h equals 1 700ths. Okay, so both of these answers are equivalent, therefore they are acceptable as solutions, so long as you plug it back in for h and check to see if you end up with a true statement. Okay, so we're just going to continue moving on because we're on a roll. So number 7, ooh, what about this one? Let's see. This looks different than the last few problems. I'm going to go ahead and do the same as always. Circle that h, split the equation so that I know that now I'm focusing on the left-hand side. So I'm ignoring the -9 for right now. So now let's see. Normally, I say it's easier to get rid of your constant first. But you're going to see in this case, because since we have a fraction involved, that's not the case. Okay, whenever you see a fraction like this, you're going to want to try to make it whole numbers, because once you have whole numbers, things are a lot easier. So let's read this first. It says 6 plus h divided by 5. So if I want to get rid of this 5 so that it's not a fraction anymore, I'm going to have to do the inverse, which means I'm going to have to multiply by 5. That's easy. Let me do that. I'm going to go ahead and multiply by 5. I'm going to go ahead and make it as 5 over 1 so that I can see that they cross cancel. But whatever I do to one side, I must do to the other, leaving me with just 6 plus h equals negative 45. Now, wow, this problem immediately became easy. So notice when you have a problem like this, it looks intimidating at first, but think of it. What could you do to make it look like a problem that you can solve? Well, what did you have to do? Just get rid of that fraction, get rid of that 5. So now I'm going to go ahead and work on isolating my variable of h. So in order to do that, I need to get rid of this 6. This is a positive 6. It's a constant. And how do we get rid of constants? We undo it by undoing the addition or subtraction. So this is a positive 6. That's basically adding 6. So I'm going to go ahead and subtract 6 to both sides using the subtraction property of equality, leaving me with h equals, let's say that this is 0. H equals, there are definitely more negatives. How many negatives are there altogether? Well, let's see. There are 51 negatives. So now, again, before you claim that this is your solution, go ahead and plug it in for h to see if you end up with a true statement. If so, the answer is correct. If not, something went wrong. You need to check your work and see where the mistake occurred. So notice that this problem wasn't that bad. So now I'm actually going to go ahead and have you try number 8. Go ahead and pause the video right now to see what you get for the solution for W. Okay, so now let's check your work with mine. So now, again, I have a dilemma. Once I circle my variable, I notice I'm focusing on the right-hand side, which is great. However, I have a fraction involved. And I don't like fractions. In fact, I would rather work with whole numbers. So what could I do? Well, I can try to get rid of this 2 because this 2 is what's making the fraction. So how do I do this? Well, first read it. It says w minus 6 divided by 2. So how am I supposed to get rid of that 2? I'm supposed to use the inverse. So instead of dividing by 2, let me multiply by 2. So notice I'm going to write it as 2 over 1. They cross cancel, creating 1s. Now this just leaves me with w minus 6. Wow, that's so much better. But whatever you do to one side, you must do to the other. I multiplied this side by 2, so I'm going to multiply this side by 2. Let's see, I don't know what this is off the top of my head. However, I know that a negative times positive is a negative. Let's do some side work. 4.5 times 2, that's 10. Carry the 1, that's 9. Move the decimal over once, so that's just negative 9. Wow, that's really easy now. Some of you could probably do this in your head. But you got to show your work, so I'm going to go ahead and circle my variable, and notice I need to get rid of this constant here. So I'm going to go ahead and add 6 to both sides. These are additive inverses, so that equals 0. Adding 6 to this side. There are more negatives. There are 3 more negatives than positives, so I'm left with w equals negative 3. But again, before you claim this is your final answer, go ahead and plug in negative 3 in for w to see if you end up with a true statement. Well, guys, that actually concludes our lesson for today. Hopefully this helped. If you have any questions on checking work, I am going to be linking a video from the previous lesson. If you have any questions, feel free to email me anytime. Thank you for tuning in. Bye.